Thank you. Thank you, Ali, for the introduction. It's really exciting to be here and to be here to talk about two of my favorite things, basically testing and games. I'll start by telling a little bit about myself, if I get the clicker working, yes. I started as a tester in 2002. I actually started my first project testing a mobile app for the old Nokia communicator, the one that would open. It was this huge thing, almost as big as our phones now. But this was before I actually owned a mobile phone myself. And I think for the most time, since then, most of the projects that I've worked on have had a mobile side to them. Or most of them, I've also had to test some mobile apps or devices or something of the sort. I've done a lot of mobile automation, and in the past few years, I've also kind of spent some time doing mobile app development as well. So this is kind of a new thing for me. Like Ali said, I'm one of the partners at Altom. We're a company from Romania originally. We do exclusively software testing, we do services and consulting, and we have some training side to it as well. We teach the BBST, the Black Box Software Testing series online in collaboration with Cam Kainer, and I'm one of the instructors for that. I do at Altom. I actually work now in Helsinki in Finland. We have an office there as well where I'm based, and I do all sorts of consulting projects or contracting projects with different companies. I currently work with a company called Zippy from Finland, where I'm the QA lead, and it's actually my first project where I'm involved in the blockchain with blockchain technology. So it's a new world for me, and it's quite interesting. So if anyone here is into that, I'm happy to talk about that as well. But the story today is mainly based on three main projects that I've worked on. The first one is a project I did a few years ago with Bitbar, also a Finnish company. That offers access to a device farm. They have hundreds of Android and iOS devices that you can access in the cloud to run your tests or your automation on them, just like many other providers out there. I started working with them on a few projects where their customers, mostly mobile game companies, were trying to write better tests to run in the cloud on the Bitbar devices using Appium. So this is one of the main projects that I'm going to talk about throughout the talk. Then the other thing is I started working, and I'm still kind of working on that project at the moment, as part of a concept development team. I was on the software side. I was both doing development and testing for that. We were building a lot of apps, trying to cover a lot of platforms and a lot of kind of different types of devices, from mobile phones to TVs and all sorts of screens, to test different concepts. So we had to kind of do a lot of fast development, make changes very fast to them, be able to bring them up and test an infrastructure of them and so on. So we chose Unity for that, even though it wasn't for games. Unity is a game engine, but we were using it for apps. A bit unconventional, but it was because of the many platforms that Unity supports, and because of the easiness of changing graphics and having them work very fast on many different platforms. And then the third thing is not really a project; it's more like a hobby thing of mine. I enjoy making games myself, and I have a few. Once I got started and got into Unity, the possibilities were endless. So I started trying to develop my own games, and I have a few hobby projects that I work on. So this is the kind of the context of me testing mobile games and working with Unity. And before I get to the solutions that we kind of try to find for different problems, I want to talk a little bit about what makes mobile games special, and specifically what makes them different from just mobile apps in general. I think many of you may have seen this. If you do any kind of mobile testing, this is probably not a new picture. The one on the left side, the OpenSignal one, is I think from 2015. I don't think they released any new information, but the situation I'm pretty sure is still kind of looks the same. So every little square on that picture represents a different Android phone model. And the bigger the size, the more popular the model was in 2015. So obviously there's a big problem there when you're trying to test something that is supposed to run on all of them. The fragmentation problem is that you're trying to serve many different devices, many different hardware capabilities with a single application that's supposed to run on the high-end Android devices and on the low-end ones. And iOS used to be better. It's getting worse there too, because there's more and more models and more combinations of things, also with iOS versions. But still, Android, I think, is the bigger problem here. The other picture, the one on the right, is from 2018, from February, and it just shows the most common resolutions in mobile in general, the mobile phones that were used by StatCounter. For games, resolutions and screen real estate is really important. So the more variety you have there, the more careful you need to be to make sure that your game still shows everything inside inside different resolutions and works well enough or shows well enough the game to be played. But of course, this is a problem also for mobile apps. It's not just a problem. Fragmentation is not only a problem for games. I just think that, at least in my experience, the way I normally deal with this problem, whether it's too many browser combinations or whatever the problem is by choosing, the most common combinations, my top combinations for users. And this is usually, some of the apps are different, but a lot of the mobile apps that are built nowadays have a very clear target market. They're, a delivery system for Chicago, whatever, something that's very local, and you can kind of look at your users and say, okay, most of them use these 10 phones. But of course, not all apps are like that. If you think of Facebook or Snapchat or whatever, something that's obviously internationally available. But most games, you want them to be, globally available. So then you kind of have to look at the most common devices in Asia, the most common devices in Europe or South America or North America. They are so different that even if you put all of those together, you still come up with a list that is really, really, might have tens and tens of devices, and it's really hard you still have a fragmentation problem within the most common combinations. And then, of course, another thing that I think is specific for games is the fact that your customers, your clients, a lot of them are going to be kids, and a lot of them are not going to have high-end devices. Again, for mobile apps, they're usually targeted at people that use mobile apps. They're going to be technology savvy. They're going to most likely have a device that's on the higher end. But kids, they might just have the devices that their parents no longer use. They're happy to put up with a bad experience with the game as long as they can play it. They still want to play it, even if it's a bit slow, even if it's not so easy for them, but they really want to play it. And this, I think, also makes games a little bit special in that sense, because, and of course, you'll always have the high-end devices as well, but you also need to care about the low-end ones. And with this in mind, I think the customers that I worked with when I started working with Bitbar, they were mobile game companies that were really trying to, because they couldn't just choose 10 devices and run all their tests on that, they were trying to cover a lot of ground and run very simple tests, automated tests, on as many devices as possible. So they were trying to run on hundreds of devices in the cloud, very simple tests that would simply just install the game, run it, see that it doesn't crash, it doesn't run out of memory, and then play the game for a little bit. Just make sure that you can play it, move from one level to another maybe, go through the tutorial, stuff like that. So very, very basic thing, nothing fancy there. And when I joined them, I think for most of there were a few clients that we worked with initially. Most of them had already made the choice of using Appium as their framework for writing these very simple tests. And I think this made sense to me, that the fact that they were already kind of set on using Appium. From a tested point of view, Appium is the obvious choice when you go from web to mobile, because Selenium WebDriver, the patterns and everything applied to Appium is basically the same thing running on mobile. It works on both iOS and Android. It has really, really good integration with the device. Installing the game, running it, all of that, going back on Android, putting the app in the background, all of that stuff works really, really well on both iOS and And it also supports, like Selenium WebDriver. You can use it with basically any programming language that you want. And of course, it also had the advantage. I think almost any device farm company there supports Appium as a framework for automation. So this also kind of puts it ahead of other frameworks that would have been available. So the mobile game companies that were trying to use Bitbar's cloud services were kind of at a point where they had some very basic Appium scripts that would install their game. That was very simple. That was trivial. They could run it in the cloud. It would start the game. They could see what's there. But then they kind of run into a new problem. And this kind of takes me to what's so special about Unity. And this is not necessarily just about Unity. It's about game engines in general. I just speak about Unity because this is the kind of my focus. There's very few mobile games that are native, mainly because if you wanted to do native apps for games, you'd have to do all of the graphics twice for each platform, and that's a lot of work to do. So I think most companies would use a game engine like Unity or like Unreal Engine that would, you do the work once, you focus all your graphics, everything, all the game logic, everything is built once, and then you just export it for many different platforms, mobile included. So this is why Unity, for example, is really popular, and game engines in general are way more popular than trying to write a native game. If we look at how, this is how the Unity editor would look this is one of their tutorial games. Basically, this is how a level or a scene, it's called in Unity, looks when you're developing it. It's just a basic scene. We have a player there, a guard, something on the wall. All of these are elements that you want to interact with. And on the left here, you don't see it very well because of the blue, but the idea is that this hierarchy here has all of the elements that we typically want to interact with when we're testing a game. This is what you normally have access to in a web app when you're finding your elements in the DOM. So this is what we want to have access to when we write automated tests. Unity has great support for unit tests and integration tests, and it's from the Unity editor and supporting Unity games are written in C#. So their test framework is based on NUnit. You can write very good tests in the sense that you can basically instantiate a player, instantiate a guard in this case, and then see how they interact together. This is kind of like the unit or integration level tests. Well, this is not the game itself. You don't test the end product. You just test components, you instantiate them, and test their integration. You can also load an entire scene, like a level like this, and test how that works. But in Unity's test framework, you are still kind of controlling the frames. You just let one frame at a time pass, and that's again not the end, kind of not the way the game is going to run in the end when it's exported and running on a mobile phone. So there's nothing for that. This is the main reason why testing is a bit more difficult when you're thinking of UI-driven test automation on mobile games. But once you've exported the game, you still get an APK or an IPA if you're on iOS, and you can use that with Appium. The only problem is that when you get into the Appium inspector, which normally for a native app shows you here on the left, you'd see kind of the same type of hierarchy of elements like you do in Unity. You don't see anything. The only thing you see with the Appium inspector is one Android view. This is for Android. It's one canvas. You still see the same elements there, but it's just one canvas that has everything painted in it, and there's no native APIs to give you those elements, and it's like a one black box, or like in the old days when you were trying to test a Flash application with Selenium. Same thing. You just have a black box. You don't see anything beyond that. So this is kind of the moment where I joined the project, when clients were kind of here. They could run the game, install it, start it up, and then there was nothing to interact with. So what they were doing was basically clicking at coordinates. They were trying to figure out, okay, doesn't go back. Okay, the guard is somewhere, like halfway on this axis and 3/4 that way, and kind of click there. If they were smart, because most of them realized that if their problem was testing on many resolutions, they couldn't go with exact coordinates. So they were, trying to be smart and say, okay, we'll try to figure out relative coordinates where to click. I don't think here, I need to explain why clicking at coordinates is not a good solution. But at the same time, I want to point out that it's only a bad solution if you don't know the right coordinates. And it's bad because even if you do know the wrong coordinates, you cannot assert anything on the screen. You just do actions and have no feedback on whether those actions were correct or not. But clicking add coordinates in itself, and you know the right coordinates, and you can assert, is not a bad thing. And this is how at Bitbar we were trying to kind of figure out our options there, and we came up with the idea that if we used image recognition, we would know the right coordinates, and we could also do the asserts afterwards to figure out, okay, yeah, something did happen, this element is now on the screen or isn't anymore, and so on. So clicking at coordinates is only bad when you're doing it like without an algorithm behind it. So for image recognition, we started on that path because of some of the algorithms available in OpenCV. These are OpenCV is like the most common, the most popular open source image processing library. It's really, really powerful. I think it's just getting more and more powerful every day. And we were using an algorithm called feature detection and matching. It's actually two separate things, but so we were not trying to do pixel perfect matches. We were not looking for the exact same image inside a screenshot from the device. Instead, the feature detection algorithms, this is a famous picture, even though it's not the greatest quality, but it's the picture used for feature detection in general. So we're trying in this case to find the cookie box on the left inside the bag there, which was also a bit covered by the rice box. And the idea is that instead of matching pixels, we're trying to match features. And features in image detection kind of means edges and corners and some other things that you're trying to identify inside an image when you process it digitally. And because the algorithm finds enough matches for this place there and the other one there, it finds enough of them, it can make an assumption about where that box really is. So the green square there shows where the algorithm assumes that the box is, the cookie box is, even if it doesn't see it fully and even if it's at a different angle and so on. So that for us meant we can actually define or get our object model or mobile elements by defining small images that we look for. And this worked really, really well. We used an open source feature detection algorithm called Akaze. It was resolution agnostic, and it really worked on different angles, rotation, and so on. I have an example here from the Sims, the mobile game, The Sims. So the picture now here on the left is the exact same, the screenshot. This is a screenshot that it's been taken from, so this is an exact match. But it also finds it if it's at a different angle, zoomed in. It doesn't even matter. In this case, the sim is no longer in the house, but it still knows, okay, this is the same house. I can find it at that angle. So this worked really, really good for the purpose of what the mobile game companies were trying to do. Because it really, you could just define your player, your guard in the previous example once, and it will really find it from many different angles and really on many, many resolutions and on different types of devices. We even had the same image for iOS and Android. It didn't matter because you simply took a screenshot and it would find it enough to say, okay, it's on the screen, it's about at these coordinates. So you clicked in the middle of that square that it gave you and it worked. Another great thing about it is that it didn't require any changes to the game. I never tested The Sims. It's just that I could take the app from the Google Play Store, and all I need to do is take a screenshot from it and then run the algorithm. So it required zero changes to the game itself. Of course, for iOS, you need a bit more a special build, but for Android, it really was this is the Google Play Store application. The customers were really by running very, very simple things, they were able to find a lot of crashes on low-end devices, a lot of out-of-memory problems, and really a lot of also graphical problems. Things like, okay, this button didn't even fit on the screen because the resolution was too small, or they had problems where things would not appear, and these brought all of those out very, very fast. So it worked really well for the initial scenarios where they were trying to run very simple tests. And just as a note, this is now, Bitbar has these examples open source as part of general cloud example. So if you want to try it, it's free, then you can go ahead and see it. But eventually, we got to a point where it wasn't fast enough, first of all. So we kind of hit some limitations with image recognition. The biggest one was that it wasn't fast enough, and it didn't work for all types of games. Some of them, like the Sims I was showing, you do something and the game reacts to that. That's fine. I can do something, take my time, take a screenshot, process it, find out things, and then react to that. But if you think of something like an endless runner, where the game is moving and you're supposed to react to it, there's just like no way you could do image recognition on that kind of stuff, because it was way too slow. The other thing that happened is that the mobile game companies, they got very confident and they tried to do a lot more with this solution. They started doing basically functional UI testing. They wanted to test all of their menus and the navigation through the game, which things that make sense, but they didn't make sense with image recognition, or at least not with this algorithm, because if you're trying to do feature matching to identify between an OK or a cancel button, there are not many features to tell the difference between those. So we would have needed a different type of an algorithm and a combination of them, and it was just not the right solution. And then it also just didn't give enough granularity. If I go back to this example, it's great that it still finds the house when the sim's not in the house. But what if the bed's not there anymore? What if the fridge's not there? When is that house no longer that house? It's a very fine line there that we couldn't, I mean, we would have had to do a lot more work to get to a point where that was reliable. And sometimes we wanted this, sometimes we didn't want it, and yeah, it got to a point where we really had to think beyond image recognition. And at this point, I was already kind of also started working on the other project where we were developing apps. So again, a lot more text, a lot more, very different context. And we really wanted to do a lot more than just the basic first few steps in a game or something like this. So I realized that I really, really want access to this hierarchy here. This is what I need to have before I can do proper UI-driven automation. But because by then I was already very much, like I knew a lot more about Unity, I realized that the moment I just insert my own little prefab there, my own little object in that hierarchy, that object knows everything about all of the other ones. So that's in my control. I could do something there that would give me the information that I need. And the first thing I tried was an idea that I stole from one of the Unity hackathons. They had this project that they still have it on their GitHub page. So the idea is the same. You place something, you instrument your game in one way or another, place an element there that basically just dumps information about the elements in the scene to the debug console log, which once the game is built and it's running on a device, that ends up in the device log. So what I would do is I would say, in this case, I'm interested constantly in the player, the guard, and whatever the picture there is on the wall. I want to know where they are they on the screen? And this thing would just dump information about where they are on the screen every second. And then from Appium, I actually try this with Python. I would have a normal Appium Python script, start the game, and then parse the log, the device log, and check the coordinates, and I could interact with any of the objects that I was interested in. And this worked. I was quite excited about it, but then immediately I realized that, of course, this was not real time. I was always like 1 second behind because this would just every second tell me information. By the time I parsed it, the information maybe was no longer up to date. So I realized that what I want is something, same idea, I want something in the game, but that can actually listen to commands and give me information in real time. So I ended up going with the idea of kind of building in a backdoor, basically. You instrument your game to have a backdoor that you can open and communicate to get your information. Also just get what you wanted, because I didn't need to know about all the other elements when I just wanted to know where the player is, for example. So this is kind of where we got to a point where I turned this into a product, let's say. We called it AltUnity Tester. So my company's name is Altom, which in Romanian literally means Alt-om is 2 words, and they mean another person. But as an expression, it means when you feel like an Altom, you feel like very good. It's a very positive expression, and you feel like renewed and re-energized. So of course, at Altom, we are all Alt people. We are better versions of ourselves all the time, and everything we build is Alt something. So this is why this is called AltUnity Tester. It's really a backdoor in the game. So initially, I just had this working with Python. I had still my normal Appium driver that I could use for device interactions, for starting the game, for doing all of that. And then next to it, I would have my alt driver that would connect to the ports that the component would open on the device, and just ask for information about. I could ask, give me the current scene, tell me what the current scene is, and the component there on a TCP socket would reply and say the current scene is whatever it is now. Same with so I basically had now access to the entire hierarchy here. So I could say, find the guard, tap on it. Tell me, or wait until the current scene is security room. I have some examples of tests right here written in Python for this. So everything that required information about the elements in the game, I did through this backdoor, through the TCP socket on a specific port. And all of the interactions with the device, like in here at the line 46 there, when I tap on the guard, that's done with Appium. Because I'm still just clicking at coordinates at this point. I just know the right coordinates and I know them in real time. Because on the socket, I would get the information instantly, and I could still, we could do drag and move across the screen or swipe. All of that, all of the interaction was done still with Appium. And then I kind of, stole the entire model of the WebDriver and built all sorts of methods for finding elements and waiting for them and all that. And I had like basically a full solution with the Python scripts. And because it was still using Appium, I could still run these in the cloud. This is a sample from Bitbar's cloud, the same game basically, but using the AltUnity driver as well. The platform, or the way you would use a cloud service, is the same as with Appium. So the exact same rules apply. It also worked. I tried it with Bitbar's cloud and with AWS Device Farm. And it works as long as you can also as long as you have access to ADB wherever you run your tests, and can forward the port from the device to the computer that you run the test on. This is the only requirement. For example, Bitbar, when you run your tests in the cloud, they give you access to a container where you have the one device that you're running the tests on available. So on that, I can use ADB or whatever on iOS and forward the port with iProxy on iOS so that I have access to this backdoor that I've opened for inside the game. So it worked also on cloud platforms, really, really like out of the box. So this was basically version 1.0 of AltUnity tester, and we decided at this point, I was talking to my colleagues, and we decided to have it open sourced, mostly because we wanted to get feedback, see if people would use it, find it useful, and of course you get more ideas and more ways to improve it and see what people really need if they need it. So we released it. It's on our GitLab page, still there. So if you're interested in trying it, it's available. For version 1.0, by far, we had a lot of feedback. It's still our most popular blog post. So it was we got a lot of positive response to this, and a lot of people, I think, started using it. We got a lot of bugs in, which is great. It's a sign that people actually take the time to tell you that something doesn't work and don't just give up on it. So it was great, but by far the two biggest questions were, when do we get the Java bindings, because it was just Python, and when do we get the C# bindings as well? Or with C#, it was more than just a binding. People were looking for built-in support for the Unity editor and for the Unity test framework. So because Unity has their own test runner on top of NUnit, it really made sense to build something for C# so that if someone wants to do that, they could just do everything from inside the same tool. So so at this point, it was still just me on the project. I was just trying to build something. But after we released version 1.0, this was in the beginning of the year. I had one of my colleagues from Altom, Robert. He joined me with working on this. And he basically started working specifically on the C# side. It was actually his university thesis. He worked on building the C# side. So this was for version 1.2. We had a 1.1 just for bug fixes, and we had that many bugs. So we did a version just for that. And then we started working on first the Java bindings. So that was pretty easy. We did that. It's included now. It's available also for Java. And then on the C# side, that was quite a lot of work. It was a lot of work because we ended up doing more than we initially planned. I have an example here of same game with the Unity editor. The Unity editor is just like any other IDE, is very overwhelming when you see it, so I actually even cut part of it so that it looks even simpler, but maybe it's a bit much too. Anyway, you can see the same hierarchy there. And the lower part is what we built for the AltUnity tester. The Unity editor supports extensions. You can kind of write your own windows there and extend whatever is available, which is great. Makes it even more complex, but if you know what tools you want to use, it's pretty cool. So this is just a bigger version of just the lower part with the AltUnity part. What we did is it's hard to see maybe the green, but those are the tests. You can see that the tests that you're writing in C# using a unit like this. You can also see them in the Unity editor. So whenever it's the same, you're kind of in the same environment all the time. You don't need to leave Unity editor. You can see their status. This is basically the same as the Unity test runner that they have built in for their unit tests and integration tests. On top of that, what we also did on the right side there, you can see we kind of automated a lot of the process needed to instrument the game. This was not trivial. It still isn't. There's really a lot of instrumentation that you do to the game still to get it to have access to those elements. But with this C# or with the Unity editor extension, we kind of automated a lot of that part. We put in the prefab there, the backdoor. We open it automatically, insert it in your game, and remove it afterwards. So you really only have it for a test build. And then we also built in the possibility to not just build and instrument the game, but also install it on the device, run it, and then run the tests against it when that's done. So Unity has also good support for integration with the device. It even builds your Xcode project if you're on iOS. So it does a lot of that for you, and we kind of try to use it and build around it from within the Unity editor. So this was initially what we planned to do, and then what we realized is that most people that will be using the C# version or the Unity editor extension are probably not going to be also using Appium, or to use Appium they have to kind of get out of that environment and include it somehow. So because we realized that for people using C# and Unity, they already have the device integration, installing the app and running it from Unity. The only thing that was still needed was the interaction with the device, the actions, the clicks, the touches, the drags, that kind of stuff that we still did with Appium. So then this is when I was saying that we did a bit more than we initially planned. So Robert started working on actually implementing all of these actions using the Unity methods and events. So we now support the input, the Unity input class and the mobile touch from within Unity. So instead of in the case of so here when we do at line 30, when we do the guard tap, this is no longer me the AltUnity driver giving us the coordinates and Appium then tapping at those coordinates. This is an actual tap on the element. It's probably, if the element has a click event to it in Unity, then we activate that, or if we actually use the Unity actions for this. So in the end, we got to a point where we have a real AltUnity driver that kind of sits along or maybe instead of the Appium driver. The Appium driver is now more or less optional. If you use C# and Unity, you don't need to use Appium basically at all. For Java and Python, you can still use the Unity apps for interacting, for touches, and for taps on elements. But then you still need to kind of do the device, the application installation, running the game, and all of that separately somehow if you don't use Appium, because there's nothing built in. So I think most people that would use the Java and the Python bindings would still use Appium for the convenience that it brings with that. But at least now it's optional, and on the C# side we can just use, or we are not dependent on Appium anymore. We're just kind of copy whatever Appium does in other cases. We're currently working on version 1.3. We released 1.2 a few months ago, I think, and we also got good feedback on, finally people are happy with the Java bindings and happy with the C# bindings. We got more bugs. So I think we already have had a release with bug fixes for 1.2. In 1.3, we kind of already realized that the moment we implemented the mobile touch in using Unity events and methods, we can also extend that for keyboard events. And then we're not just tied to mobile platforms. We can do the same thing to even the same game if it's exported for a console or for a PC, or so it's just we still just need to connect to a port, and then once we do that, we can support any of the platforms that Unity supports. So that's one of the things that we're looking into, and then the other one is trying to build, again copying Appium, trying to build an inspector, because people that don't use Unity, and this is the case still, at least for some of the people that we've talked to, or the cases that we've had, you have to. Sometimes the testing team is totally outside of the development team, and they don't even have access to the code. They just have the game, and we've had people that would say, but we can get the build instrumented. We just want to run the test with AltUnity tester. I know this is not the ideal situation, but apparently it is happening. And those people are stuck because they don't see the hierarchy. They have access to it, but they don't know what elements are there. So we want to build an inspector to kind of help them. If you have the build instrumented, the inspector would just connect to the same port and give you all that information, show you what elements you have access to, and it'd be just easier to use them. This is something that I think Robert this morning, I was awake at like 5 in the morning, and he very happily sent me the first version. Apparently the UI was so bad, he told me in the first place that he's not focusing on the UI, but it was so bad that he had to send me also some instructions of what everything does. So, but anyway, it's very exciting. We have something already, so this is ongoing now. I just want to leave you with both of the links, because all of them are available, and you can try them and use them if you want. And I want to say that even though I'm very excited now about the second option, I would still recommend using image recognition for the cases when you're not interested in very complicated scenarios, in testing anything too complicated, because it's so simple and it's so kind of straightforward to use. And like I said, it requires no instrumentation. It's really the game that you're going to put out there in production, compared to the second case where you have a lot more control, but then that comes at a cost of having to, especially now with the input, we really simulate a lot of the stuff that normally goes through very differently if you're not using the AltUnity tester. So there's a trade-off there in both cases. I will have office hours. I was wondering if I should show something in action during but it's only 40 minutes. It's too little time to actually do that. So I have office hours from 1 p.m. after lunch. I'm happy to show this to anyone who wants to see it or talk about anything related to this. So please stop by and ask anything. Or I'm on Twitter, also happy to answer any questions. So thank you.